This is a DC motor transfer function experiment. In this we are conducting the experiment to find KB and KT, that is back EMF constant and torque constant. First we are doing the circuit connecting the circuit for running the motor and generator set, where the input is given to the DPSC switch with the fuse, and one of the positive supply, the positive of the switch is given to the rheostats of the both field and armature winding. This is coming here. This is the armature rheostat, and it is given, and the output is taken from this one and given to another rheostat in series. Because our rating is 50 ohms, 250 ohms, that is 100 ohms, 5 amps rating. So we are connecting 250 ohms 5 amps rating in series, and we need to ensure that the armature rheostat should be in maximum position. So if we are connecting the input here, the resistance is fully connected and it is traveled through here, so it is in maximum position, and the input is here again. So from here the resistance will completely traveled, and from here it is coming as output, so it is in maximum position. It is given to the ammeter positive. We should ensure that it is a moving coil. It should not be a moving ion. That is for DC ammeters. So this one it is given to the positive of the ammeter, and from negative it is given to the armature of the motor, armature winding of the motor. And from armature negative winding it is shorted to the field F2 and the negative supply. So from armature A2 it is shorted to the F2, that is a field negative, and it is given to the that is armature, field and the negative terminal, everything is shorted. This negative to the armature is shorted to the field. And at last we are measuring the voltage using voltmeter. That is across it can be either across armatures or across this one. We are using positive to the armature and negative through the field we are adding. Now motor side circuit is completed. Mechanically motor and generator are coupled. Now we are going for generator side circuit. I will explain this field winding of motor also. Like initially we gave one winding to armature rheostat and field rheostat. This the second winding to the field rheostat, and the another terminal is given to the field ammeter. That should be rated of 0 to 1, because the rated field current is 0.5 for this motor. So only 0 to 1 rated ammeter is used, and then from the ammeter negative we are giving to the field F1. And in motor the field rheostat should be in minimum position. That is armature rheostat should be in maximum position, field rheostat should be in minimum position. That is the supply is coming here, and directly from here we are taking the output. So it is a minimum position. Now we are going for generator side.
Why they are keeping like that?
Because in field winding already has a higher resistance, so we can keep it minimum. Armature resistance will be very small, that is in the range of 0 to 3, 1 to 3 normally. So we are making it as very large, such that the motor should not start at a high speed. So we are making, later only we will adjust this to make the rated speed. So now we are going for generator side. Now generator acts as the supply. From generator armature we are giving to the ammeter, generator to the ammeter, and ammeter to the load here. This is a 3-phase load. We are shorting all the phases to make it as a DC load. So this is a three-phase load we are using. So, and then from the load it is given to the negative of the armature. From the load it is given to the negative of the armature. So we completed the main armature circuit. Now we are using separate.
Short circuit. Load cell.
It is a 3-phase load. So we are shorting all the RYB 3. That is star means RYB. If we short all the 3 means it will be our effective load will be R by 3. So we are increasing the load, increasing the 3-phase load. Currently now our load is R by 3. And then this is a separately excited DC motor. So separately I am giving the supply to the field. That is, the supply comes here. It comes through the DPST switch, positive and negative, and that is given to that positive is given to the 600 ohm 1.7 amps rheostat. Here we are using 300 ohms, two 300 ohms 1.7 rheostat connected in series. And in DC side, in generator side, the field rheostat should be at maximum position. So initially it should be here. So if you see here, it is coming here and it will travel here, it will go here, and so it is maximum position. From here it is going to the second in series, again it is fully traveling and coming out. And that output is given to the F1, that is connected to F2. F2 and F1 is connected to the switch negative we are connecting. And this is the overall circuit of the circuit. Now initially we are switching on. First, after ensuring everything, we are switching on. Then we are switching on the supply. Now the motor will start at low speed, and we need to always ensure that our motor armature current is always within 5 amps, because all our rheostat we are connecting in the armature side are rated for 5 amps. The motor rated is 6 amps, but our equipment, our rheostat will not handle more than 5 amps. So this current should be ensured that it is always lower than 5 amps. And from the nameplate we can see the rated field current is 0.5. So here it is showing it is now running at 0.7. So we are reducing first to 0.5 by increasing the field resistance. That is below 0.5. Now I am keeping around 0.45 the field current. Now we are used to take diameter. Now we need to keep the rated speed in the motor. The rated speed is 1500 rpm. So we are reducing the resistance. We need to adjust the armature rheostat to reduce the speed. So now we will get the armature voltage, armature current, change the current to speed. We will note the reading, and then we will reduce the speed is reduced. Again next reading we will reduce. Like this we will reduce for around 4 to 5 readings. Now this completes the KB finding part. The readings are enough. Now we are going for load set, that is K2, that is a torque constant. Again we need to keep it in 1500 rpm. Now it is near 1500 rpm. Now so now we are switching on the DC field supply. Now DC is switched on. Now check the voltage across developed by the DC motor, the DC generator. It is only 22. Now we are we need to get the rated voltage in the generator side. So we are adjusting the field rheostat of the DC. Don't hold me here.
22.
Why only 22 is there? It should be high now. Fix the speed there. Load is half only now.
Loading off.
I'll check the voltage. Don't hold me here. Please show me why it is not necessary. No, this is the place. It's up.
It's 140.
Now we are getting the indicated our rated is 220 volts, so at least 210 we need to get. We got rated voltage, so you can take. Now we need to start the load. Switch on the load. Now we can take one no load reading with all the currents, everything. Now always add lowest load, 0.5 loads. Don't go for 2. There is 0.5 in the lower bottom. We go for first 0.5. We need to check the main thing is this armature current. That should never exceed 5. So now it is around 3.1. Next load. We need to take the readings. Again next load. Now around 4. Next. Around this. Now we till now if we increase the load it is crossing the 5. So we are stopping it here. Now it is. One by all the loads reduce one by one. Switch off the load. Now generator side is not our problem, so the same process. Now this is the secondary set of reading. In third set of reading, what we need to do is we will fix some constant load in the generator side, and then there is a field. Now in the same process we will start the motor. We will get the rated speed by adjusting the field and armature winding. Now it is set. Now we are starting the generator side. Generator is started. Now we get the rated output voltage of the generator. Now switch on the load. First there, down. After switching on the load, put one load. Here we can see it is reaching the half of the rated current. Our motor rated current is 6. We are getting half of the rated current. Now we are fixing the load there itself. Now we are going for field beginning method. That is, we are adjusting the field current. So if we reduce the field current, our speed should increase. So here the field current is around 4.5. We are increasing the resistance, means the field current will reduce. We will take around 3 to 4 readings. Till maximum we can get. So around till 3.5 small variation. Till 3.5 we will get the reading. Now in the same thing. First we will reduce it to this same as we started. Switch off the load first, that one, and then load off. Then everything is same as the starting integer. In this, initially we will get to these three values for the first reading. IF is fixing as constant. So and RA we are assuming 3.5 from the motor. Now EB is VA, that is armature voltage, minus IA area drop, that is EB. And then the RPM we are converting to the radians per second. Now we will plot EB versus radians per second, that is EB is equal to KB into omega. So from the plot slope we will get the KB. This is KB is finished. Now we need to find KT. We will get speed, armature voltage, load current, and then armature voltage current. Now torque is equal to the developed torque we need to find, that is not the load torque, the power. So we calculating the input power VA into IA divided by speed, that is omega. Omega is 2 pi n by 60, that into 60 will be here. So torque we are getting. So our torque is equal to KT into IA. So KT we will find from the slope by plotting torque versus current. Now for field weakening control we are only calculating the KT. There is no KB there. So for that we will get the speed VA, VL, IL. IL will be always constant because there is IL is that side, that load. IA also will be constant because they are fixing at a half rated voltage, 3.1. That will be almost constant always. Here constant. IL also will be almost constant. IF is the field weakening, that is 4.9, 4.5, 4, 3.5, some 4 readings. Now with the IF we are having torque is same, this equation, the developed power divided by the speed. So VA into IA divided by 2 pi n into 60, that equation. We will get the torque. So IF and versus torque we will plot. In the field weakening mode, torque is proportional to KT into IF. So we will get the KT. That's 3 graph. That is, we need to open the cap and measure the.
Oh, okay. Now here it's directly we are giving 3.5. Rather than we can measure it.
Or we can measure here. Or best is we need to remove this and measure the resistance R of the armature winding.